Hello guys, welcome to my channel. Our channel name is Engineering Knowledge 101. By the way po, if you are a first time or bago pa lang kayo sa channel, kindly support po guys. Kindly subscribe and like para mas marami pa kami ma-share na videos in future. So to continue here, I want you to share some knowledge regarding fluid mechanics applicable for engineering students who are studying in colleges. Our topic today is about Venturi pipe. Okay, I have here a sample problem. As you can see here guys, a perfect Venturi with throat diameter of 1.5 inches is placed horizontally in a pipe with a 4 inches inside diameter. Okay, having a liquid of 70 pounds of water flow through the pipe in every second or 8 seconds. And the problem here is, what is the difference between the pipe and the Venturi throat static pressure? So, to understand more, I've shown you here regarding the Venturi diagram. As you can see guys, para siyang cone, para siyang concentric cone at saka eccentric cone na magkadugtong. Actually, it's a pipe. We called it in the engineering as a Venturi. So we have here the size for the Venturi, 4 inches for the pipe, entrance pipe, and the throat diameter is 1.5 inches as mentioned in the problem. So this area, this point is the point 2, and here is the point 1. So of course, the liquid before entering the Venturi, there is an initial velocity sa B1, and at the same time there is a corresponding pressure or P1. The mass of the liquid entering in the Venturi is 70 pounds per seconds. And then the output or the exit is the final velocity with corresponding pressure. Now what as in this problem is the difference between the pipe and Venturi throat static pressure. Okay, so to solve this problem, to continue the problem, I will show you the solution on how to solve this problem. Okay, so we have here regarding fluid mechanics, this Q is equal to V and A is a volume flow rate equation. As we go back in the fluid mechanics, this is a general equation for the volume flow rate. Q means the flow rate in gallons per liter, gallons per second, or gallons per minute, and the V is the velocity of the fluid or liquid, and the A is the cross-section area of the pipe or the Venturi. Okay, now to proceed, we need to solve first the initial velocity. We need to solve first the initial velocity of the liquid before entering the throat of the diameter of the Venturi. So we represent this one as a V1. Okay, from the original equation, we derived the V1 is equal to Q over the area of the pipe. By the way, the diameter of the pipe is given, which is 4 inches. Okay, so knowing all the data, we have to simply substitute the values in this equation. Q is the mass flow rate or volume flow rate, which is 70 pounds per seconds, divided by 62. By the way guys, bakit po natin din divide ng 62.4? Para po ma-convert yung pounds per seconds into cubic feet per second. Because we need all the units to be consistent. So 70 pounds per second divided by 62.4 pounds per cubic foot. So ang result po ng units ito sa numerator is cubic foot per second over the area of the pipe, entrance pipe, which is the diameter given, which is 4 inches. So area of pipe is 5d squared over 4. So substituting the values, we have the 4 inches divide by 12 inches to become a feet. So i-squared lang po natin yan para maging feet squared, para consistent po yung unit. So by dividing these values, we have here 1.1218 over 0.0872. So dividing these two values, the result, V1, or the initial velocity of the fluid entering the pipe, is 12.86 feet per second. Okay. After solving the initial velocity, again, we need to solve for the final velocity, output velocity after the throat diameter of the venturi, after the venturi, the final velocity of liquid. So again, by using the same equation, V2 as a final velocity is equal to flow rate over area, volume flow rate over area. So again, just simply substitute the data, 70 pounds divided by 62 over the area of the venturi meter. By the way guys, the diameter of the venturi is no longer 4 inches. It is 1.5 inches, as stated earlier in the problem. So because we are solving now the final velocity of the venturi meter, so the diameter should be the 1.5 or the smaller size. So by calculating these values, the final velocity of the liquid after passing the venturi is 91.2 feet per second. So now we have already the initial and final velocity of the liquid. Next is we need to solve for the pressure difference of the venturi between the pipe and venturi through static pressure. So by applying Bernoulli's equation from fluid mechanics, as we all know, P1 meaning initial pressure over the unit weight of the liquid plus the initial velocity over the twice of the gravitational acceleration plus the initial elevation is equal to the final pressure over unit weight of liquid plus the final velocity over the twice the gravitational acceleration of the liquid plus the final elevations. As you can see here guys, in our diagram, since there is no elevation difference, we assume that the venturi is in horizontal position. So now for horizontal position, the elevation are equal. Z1 is equal to Z2. So these two parameters will be cancelled. Z1 and Z2 will be cancelled because they are all equal. Okay, so the remaining equation is the difference between the P1 minus P2 over the unit weight of liquid is equal to the difference of the velocity from B2 minus B1, meaning from final velocity minus initial velocity over the gravitational acceleration. So by substituting the values, the unit weight of water as a standard is 62.4 pounds per cubic feet. Okay, as you can see here guys, sinasubstitute po natin. And then we have already solved the final velocity. How much is our final velocity? As we solved here earlier, we arrived 91.2 feet per second, and the initial is 12.6. So by simply substituting here, 91.2 to the power squared minus the initial velocity is 12.86 feet per second to the power squared over the gravitational acceleration. This is 2 times g. G means gravitational acceleration of the liquid. By the way, our standard acceleration or gravitational acceleration of liquid is 32.2. Why is it is 32.2? It is a feet per second squared. Okay? Ang unit po ng 32.2 is feet per second squared. This is standard values. So by simplifying this expression, we have here 8317.44 squared from the original expression. And here, by squaring these values, we have 165.38, okay, feet per second. And divide the product of these two expression or values is 64.4. So by simplifying further and by cross multiplying this one, 62.4 pounds here. So this is the expression by simplifying this to all these parameters. So to calculate further, P1 minus P2 is equal to 7,898.89 pounds per square foot static pressure, or is equal to 54.8 psi. Kasi yung conversion po ng 1 feet is 12 inches to squared para makancel po yung feet squared natin. So, ang labas po niyan will be pounds per square inch, which is equal to psi. Okay? So, ang equivalent nitong 7,898.89 pounds per square is equal to 54.8 psi. So, this is the final answer to our problem. This is the difference between the pipe and the Venturi tooth static pressure. P1 minus P2 is equal to 54.8 psi. Okay? So sometimes this will be applicable in engineering, especially for civil and mechanical in construction. Kasi minsan po may mga time na kung paano mag-laying ng mga pipes, mga pipeline na may mga Venturi type. So minsan na applicable po siya sa construction or even sa mga power plant o sa mga So I hope you understand one of our example problem for fluid mechanics. So again, kindly subscribe po and kindly share and like para mas marami pa tayong future coming videos na may share sa inyo guys. So just keep in touch and don't forget to subscribe. Okay, so thank you for watching and have a nice day. Bye bye.